Moving on with our circuit, we're going to reduce the output level from this buffer amp. 1.228 volts line level is over 1 volt, and it's pretty hot. And what's going to happen is in a few minutes here we're going to build a clipper circuit, and the resistors have a forward bias. The diodes have like a forward voltage of a little under a volt. And so if you're coming in with an input level that's over a volt, it's really going to clip the hell out of the signal. And that's going to not be what we want. We want it a little bit smoother, more rounded, some more soft clipping sort of thing. So we're going to want to reduce the voltage coming out of this op amp. And we do this in two ways. We're going to put in a simple voltage divider, and then we're going to put a drive potentiometer that we can vary. So let's do this. We're basically going to put a simple voltage divider with a 1K and a 51K resistor here. So let's do this. It's pretty simple to do that. We'll go back over here, and I'm going to put a 1K by 51K voltage divider. So I'm going to drag this guy back here. But hold on. Click on it. And do I select it to drag it back? Ooh, I'm having issues here. Selecting. Oop, I've never seen that ever happen. I wonder if that will happen again. That was the first time I've seen that. Go on, let me do that. So let's just add a 1K resistor here. And of course, that's the palette tool. Boop. And I'm going to junction it, make it a little bit longer here. Didn't want to do that, escape. And I'm going to click on the junction. I'm going to zoom in. I'm having issues here. And going to drag a little bit further and make a junction there. And now I'm going to make another line, J for junction. Drag a wire down here, conductor there, and make a junction. Now let's put a resistor here. I just hit the letter R, and I need to rotate it. And I'm going to zoom out a little bit, and I'm going to put another ground down here, and just to be somewhat anal retentive, I'll make it look similar to where the other grounds are. And you feel free to be as anal retentive as you want in your circuit design. Obviously, there's an art to this. Now, I said 1K by 51K. Don't be alarmed by this out-of-date thing here. This just means you haven't stopped it and started it in a while, the measurement, and things have changed in the circuit. So I'm going to double-click and add 51K here. And we have now put a little voltage divider in, and I'll put a little junction there. J for junction. We're going to continue this circuit on in a second here. Let's just go to here for a moment, and I'll go a little bit further. I'll go right there. Let's go back to the instructions and see if we've forgotten anything. We've done this. The next thing we're going to do is put in a potentiometer like that in there. Potentiometer is basically another voltage divider, but it's variable. You can change the ratio of resistance between the in and the out, which is kind of cool, between the ground and the out. So it's like varying this resistance. So it's another volume control, right? And we're going to put a 10K potentiometer in there. So let's do that. We're going back here. The potentiometer, where is it? I think it's in resistors. Yep, there it is, potentiometer. And so we'll put that right here. The input's going to go into the center lead. And we need a ground because it's another voltage divider. So we'll put that right here. Of course, we got to connect those two. So drag it up. And we're going to have an output from this. So we'll drag this over here. And we'll put another junction there. And again, it's a 10K. We're going to leave it default to 50% right now. So it should be half on either side. The same resistance on either side of the input and the output. And I think we're going to test this next. Let me double check here on the instructions. I want you to measure it first. So let's bring over this little blue probe and put it at the end. And let's run it. And we'll stop it. And I'm going to hide this and see what the value looks like. Looks like it's at this particular moment in time, it was 1.19 volts. And over here, it is 0.976 volts. So you can see it has definitely reduced the level. Okay, cool. And we'll play with the drive knob in a couple of minutes when we get to the distortion. But if I were to change this value here, it would change the voltage. So we've got our little circuit happening here. And this is, I believe, if we reach the next, we are getting the cool part. We get to see this on the oscilloscope. So to get this on the oscilloscope, we're now going to use interactive mode up here. And let me get the oscilloscope open. You can view the oscilloscope under graphic, or the grapher. This is the grapher window, or we can go back and see the schematic window. I prefer, and you're going to be using for this assignment mostly split views, so you can see them both at the same time. And this is the oscilloscope. It's pretty zoomed out right now. We're seeing bunches of seconds of cycles here, so it doesn't really make much sense. I definitely want to play the oscilloscope. You'll get, and you can see now it's playing. Now obviously we want to zoom in and see the waveform. Open up this toolbar over here, whatever we want to call this, configuration pane is what they call it. And this is pretty key here, your time per division. This is how much time is going to be shown on the screen. Right now we're showing 50 milliseconds. So I'm going to zoom in down to a couple cycles, and now you can see the oscilloscope. So you're definitely going to want to do that, and you may have to do that a couple times during this lab. Sometimes it seems to forget its settings. The other kind of critical thing here is that the maximum minimum voltage is within the operating range. Right now we're within 1.5 volts positive and negative, so it's not zoomed in too far on the y-axis. You may need to hit the normal button to trigger. If you end up in one of these other modes, strange things can happen. But we are still live here. If I drag this over, you can see both of these values are live. And of course, what we're seeing here is green is the input voltage coming into the buffer amp, and it's higher than the output voltage coming out of the voltage divider, which is cool. And might as well show you this while I can, because it's pretty cool. You can play with this the value here, and look what you can do. You can add some gain, and you can turn down the level. And this is going to be our drive circuit into the clipping distortion box in a moment. I'm going to put this back to 50% so it looks like the drawings, the images in the instructions. But we're pretty good here. I would save if I were you. There's nothing wrong with that. Kind of make sure your circuit is good and saved. And we're going to be on to the screenshot thing, because this is your second submission here. This is called, take a screenshot of the screen and call it to voltage divider your name. I'm not going to do this myself in the video because you already know how to do it, but please name your screenshot to voltage divider.your name, and that will be submitted and show me that you've got the circuit and you're playing with the oscilloscope like you're supposed to. Cool. All right, end of this video.